Statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make a decision. So that's basically the whole process. You collect your data, you organize it, maybe you look at some pretty graphs or charts or something like that, analyze what's going on. That typically follows from looking at the graphs and charts. And then interpreting means you're trying to predict the future. That's where the big money is made in the field of statistics. Can you predict the future? There's two types of data sets. The first type is population. This is the collection of all outcomes, responses, measurements, or counts that are of interest. For instance, let's say I wanted to know the weight of all watermelons in the world. That would be the population. I would have to go and physically weigh or somehow gather data on every single watermelon in the world. Now, do y'all think that's practical? No. So, if I can't do that, then I'll get a sample. A sample is a subset or part of a population. So maybe I can't get every watermelon in the world, so I'll sample them at random. The reason I say at random, like I said, I like to kind of spill the beans early, is if I just sample the watermelons in Texas, do you think the watermelons in Texas are representative of those in China? No. Different growing conditions. Different climates. So if I really wanted to look at the watermelons of the world, I would have to sample from all over the world. Okay. So let's talk about some things with the population. In these circles, we're going to put symbols. Don't worry so much about how to calculate the symbols. Just start learning what they mean. Like if you see them, I want you to know, oh, that's population mean. Oh, that's sample variance. So for population, things that we can look for are mu, which is the mean. Sigma squared, that is the variance. Sigma is called the standard deviation. We can have P, which is a proportion. Capital N is our population size. But then, those are symbols for the population. We also have equitable ones for a sample. If I'm talking about a sample mean, that's going to be X bar. So that's our sample mean. Sample variance is S squared. Sample standard deviation is S. I'm going to abbreviate standard deviation as STD dev. P hat is our sample proportions. And then a lowercase n is our sample size. So what we just labeled here, or what we just wrote in these circles, for population, that's called a parameter. A parameter is a numerical description of a population characteristic. So let's say by some miraculous event, I was able to figure out that the average weight of all watermelons is 15 pounds. Then that would mean that mu is equal to 15. That's a parameter. That tells us about the population as a whole. These always stay the same. Parameters always stay the same. They're never going to change. Unless your population itself changes. So, go here. These are always the same. A more practical example of that would be, let's say I wanted to find the average age of everyone in here. Now, chances are it's probably around 17 or 18. But if I went through and I got everyone's age, added it up, and divided by 20, since there's 20 of y'all here today, that would be our population mean. But let's say I'm like, I don't want to do that. That would require the use of a calculator. And I got a sample mean for the age. This is called a statistic. It's not a parameter, it is a statistic because it talks about the sample. The way you can keep these straight, population parameters, sample statistics, PPSS. If I just said, okay, I'm going to pick 5 of y'all, add your ages up, divide by 5, there's the average age. That would be X bar, because that's a sample. Sample statistics can change from sample to sample. Notice I'm not saying it will change from sample to sample. I'm saying it can change. If I pick 5 of y'all that are 18, and that's one sample, well then the average age is 18. If I'm like, okay, I don't want those 5, I'm going to pick a different 5. And, what's that? It'll probably be different, but is it possible for me to still pick 5 people that are 18? Yes. So it'll probably change, but it doesn't necessarily have to change. Population, it can't change. It's always going to be that number. Okay, so just to kind of give y'all an outline of what this course is going to entail, we're going to be bouncing back and forth between these all semester long. So, at first, we're going to be going from a population to a sample. That's going to be done in chapters 3 and 4 when we deal with probability. That's, like I said, that's going to be chapters 3 and 4. But then once we get past chapter 4, chapters 5 through 9, we're going to be going the other direction. We're going to be using samples to estimate parameters. So this is where we use statistics. And we do that to gain info. Like if I take 20 different samples in here, and the average of those 20 averages is like, let's say it's 17.9, well then that tells me something. I didn't just take the average of the whole class. It's like, okay, the average of the averages is about 17.9, so that means that most of us in here would be closer to 18 than 17. I gained info about the population without surveying the whole population. Does that make sense? Okay, like I said, this is going to be more chapters 5 through 9. So we're going to use sample statistics to estimate population parameters. We'll actually start a little bit of that before spring break. Okay, so let's look at an example. In a survey of 720 employees in the U.S., they were asked if they thought their jobs were highly stressful. Stressful? I don't know what you're talking about. I only look like I'm 80 when I'm 30. What do you mean stress? Anyways, I digress. Of the 720 respondents, 446 said yes. Identify the population in the sample, and then describe the sample data. Okay, so what would our population be? So the population is everybody that we're interested in getting data from. So let's keep that in mind. Would the 720 be a population? That's actually our sample. So 720 that we collected data from, that would be our sample. 720 employees. And let me back up. Employee responses, not the employees themselves necessarily, but the employee responses in the survey. That's our sample. The population would be all employees in the U.S. Let's say I want to see if the work environment nationwide is causing people to stress too much. I'd go out and I'd do a survey of 720 people. So I'm interested in nationwide. Nationwide is on your side. I'm interested in nationwide things, but obviously I can't go survey everyone in the nation. So I'm just going to pick 720 people. Okay. So that's our population. This type of example often trips people up. But just remember, population, it's all of the people you're researching. So all employees in the U.S. The sample is the 720 you actually were able to reach. I'm going to kind of just highlight that just to make the connection, color code things. Okay. Now we're not done though. They ask us to describe the sample data. Well, let's take a look look at the data now. What do we know? We know there are 720 total. What else did they tell us about this data? 446 said yes. Their job was highly stressful. How many said no? How can I figure that out? Just subtract them. So they didn't give us that information, but we could easily calculate it. 274. Okay. We could even take it a step further. I can figure out the percent that said, yes, their job is highly stressful. I could do 446 over 720. Which would give us roughly, I'm going to do approximate sign. It's not equal because it's not exact. 61.94%. So this is what percentage said yes. This piece right here is an example of a sample proportion. Sample proportion. What symbol did we use to represent sample proportions? P hat. I always laugh when I write it out, because even though we talk about it now, when we get to it, I always like to write out how you say it. Almost looks like I'm saying a slang of fat. P hat. Anyways. Questions on that example? Okay. Let's look at the next one. Angelina College has 5,148 students, of which 1,699 are full-time students. Do these numbers describe a population parameter or a sample statistic? What do y'all think? Are those numbers talking about a parameter or a statistic? Parameter? What made y'all say that?
Because it's the whole college.
It's the whole college. That's right. So this is going to be a parameter. Because we're looking at the whole college. For those that are kind of like, huh, how can you tell? The way we can, a couple of key words to look for, they tell you the total, and then they say, of which, so they're talking about that many out of the total students. Questions on that one? Okay, let's flip to the back. We have a little bit more, and then we're done for today. You just have this top piece. Okay.
This is one less and this is another one.
That's right.
Alright.
Yeah. Okay, so we have two branches of statistics. The first branch, you may have been wondering on the front, like, where'd chapter 2 go? You said 3 and 4, you said 5 through 9, where's 2? It's this descriptive branch of statistics. We have descriptive statistics. We're going to look at those in chapter 2. That's where we organize, summarize, and display the data. We put them in charts, we put them in graphs, we find the mean, the standard deviation. We just kind of get some basic numbers from the data. Then, once we know those basic numbers, we can move on to the next branch of inferential statistics. That's where we're using a sample to draw conclusions about a population. So once we know all their statistics, we can go in and try to predict the future. So this is our chapters 5 through 9. Those are inferential statistics. We're trying to see, based on our sample data, can we reasonably say this about a population? Okay. Let's look at one last example. It's really the same data as before. I don't even know why they repeated that same question, because it's not the same question. Angel Union College has 5,148 students, of which 1,699 are full-time. This question doesn't really go with this example. So that's just, you can mark it out if you want to, but that's our old question. Now we want to break it down into descriptive and inferential stats. So what can we do as far as descriptive stats goes? Well, how many students does AC have? Okay, so AC has 5,148 students. And then what else do they tell us to describe the data? Yep. Of which 1,699 are full-time. So they really already did that work for us. Bless you. Ideally, you would start this whole process looking at all 5,148 records, looking at, like, oh my goodness, how am I going to figure this out? And then you just go through and count up how many are full-time. Of course, you're not going to physically start counting 1, 2, 3, 4. This would be done in like an Excel spreadsheet. Create an Excel spreadsheet, tell it to count the number of full-timers. It would give you that count. Okay, what could we infer? So, I mean, descriptive stats is just what's at face value. How can I take this a step further? What? You can compare it to other colleges or universities? Okay. What if I was just interested in AC? We could figure out how many part-time, or we could not even do that. Inferencing, you're just kind of making almost vague conclusions. So I could say that most are what kind of students? Most students are part-time students. That would be an inference that we made from that data. We didn't calculate hard numbers. We just said, looking at the data, the majority of your students are part-time. That's typically how they phrase it. Is you don't want to say absolutely when you're talking about these drawing conclusions. Because really, statisticians are more or less hired as consultants to come in. So if they said, well, I think this will happen, Or if they come to you and say, this will happen, and it doesn't happen, it's like, oh, you told me it would happen. I'm going to sue you now because you were wrong and I wasted money. So they don't say this will happen. This could happen based on your data. It's like, oh, well, you said this could happen. Yeah, I said it could. I didn't say it would. That kind of covers their behind, basically. Okay. Any questions on today's lesson? Okay. We are